Hello, in this video, I'm going to be showing you how linear regression works. It's actually a lot easier than you think. It's very intuitive and it's actually fun. So let's get into it. Hopefully you already downloaded that notebook from Canvas. So I know I have that inside my download folder. I'm using Mac, so I'm opening terminal so I can run Jupyter Notebook here. If you're using Windows, probably you should open your Anaconda PowerShell prompt and just go through whatever folder that you have all your files and run Jupyter Notebook there. On my system, it's going to use Safari for me to run Jupyter Notebook, but I don't like Safari. So what I'm going to do, I'm just going to copy this link from the terminal, and then I'm going to actually paste that link on Chrome. So instead of Safari, I can actually use Chrome. Okay, so I have that thing right here. All right, let's go through it. So we're going to be using some available online data set that is already cleaned and everything. So again, before you run any model on your data, you need to make sure your data is clean, transformed, and you know what features from your data frame you want to work with and you want to use, the features that you feel like they have effect on your model and what you're trying to do. Again, the goal here is that we want to predict some numbers, some values through linear regression. So, okay, let's go one by one. It's actually extremely easy to learn and run linear regression model. We're going to use scikit-learn library from Python. So the first thing we're going to do, I have this online data, basically has some advertising information about it. We spend a bunch of money on different products, and based on that, we want to predict the sales on those products. So this is how the data looks like. We have like how much we spend for advertising for TV, radio, newspaper, and these are the sales. So basically, this is what we want to predict. This is what we call a target or label value. And these are input features. So we provide data about TV, radio, and newspaper, and basically we want to predict the sales. Okay, first thing first, I don't like this column, so let's get rid of this. It has no use for us. So by this code, we're going to get rid of this column that you see here, just to clean the data a little bit. Like I said, the data is already cleaned, but we can still work on that if we want to. So I'm just going to loop through all the columns, and all the columns with this, I'm just going to drop them. And let's get some information about data. So we have 200 rows, and on each row we have 4 columns, as you can see: TV, radio, newspaper, and cell. And we can see what each column we have. So these are going to be the input features that we're going to use to train our model with, and this is going to be what we're going to predict. So this is going to be our target. This is going to be our label data that we already know all the answers. So let's see if we have any missing values, which we don't. Okay, so we're going to use these columns. Like I said, TV, radio, and newspaper. And that's going to be our X, our input feature columns. So now this X is a two-dimensional table or data frame. Each row has 3 columns. The first column going to be about TV, radio, and followed by newspaper. And this Y is going to be our target column. These are the answers that we already actually know. So the first thing that you need to do for training a model in supervised learning is you want to split your data into training and testing. So we usually grab 80% for training, and we usually leave 20% for testing. So you should not use your testing data for training because your model already seen that, so already kind of knows all the answers. So we put aside 20% of the data that the model hasn't seen before. So when we test our system with that, we can actually evaluate, see how good our model is doing. So how do we separate the data? Well, we're going to use this library, this method that we already imported at the top right here from scikit-learn. Basically what we do, we said, okay, this is our all the input features, all of it. These are our target values. These are the answers. We want to grab 20% just for testing, and we just put some random state. So every time we run this, we can get the same result. So basically what it does, it randomly picks 80% of the data for training and 20% of the data for testing. That's why you need to set up some random seed. So because if you don't do that every time you run this, it's going to give you a different result. But for consistency, we want to get the same results, which is why I set this one here. And this method returns 4 set of data. So the first one is going to be our input features, 80%. I'm just going to save it inside this variable. I'm going to call it xtrain. This is going to be the input feature that I'm going to use for training my model. The second return data is going to be 20% input feature, which we're going to use for testing. The third one is going to be 80% of this guy, our target value, again, which matches this 80% of xtrain, this input features. These are the answers for all these values that we have here. And 20% of this guy, which we're going to use for testing, and these are actual answers for these input features. So that's it. Let's run it. So we're going to end up with 160 out of 200, which is basically 80%, and 40 rows only for testing. Okay, so far so good. But how do we create a linear regression model? So in the previous videos, you've seen how linear regression works. We have a simple math behind it. It just keeps running it. It already has all the answers. So the goal with the linear regression is that it can actually adjust weights and biases. And the weights are kind of how important each feature in the data is. So for example, in our data, we have like TV, radio, and newspapers. So our linear regression model is going to assign a weight to each one of these, how important each one is, and a bias point. So the bias point basically works, okay, if none of these data are available, this is going to be our starting point. So this is going to be the sell price that we're going to start with. So basically, it already has all the answers. So it just picks different weights and biases and then checks the actual answer, and based on that it adjusts itself. And that's basically how it works. So we're going to use the linear regression function from the scikit-learn again, which we already imported at the top, and all you need to do for training, you just call this fit method on it, and you just give it your training input features, your training data, and all the targets for those training data. Keep that in mind. The bigger your data is, your model is going to be more precise. It's going to be more accurate. Right now, we only have like 200 rows. This is nothing, okay? You usually want to have a very big data, into thousands, even bigger data. So why? Because if you don't use a big data, your model is not going to be generalized. So when you provide the test data to it, it cannot actually predict those perfectly. So you kind of want to provide as many different data possible. And this is one of the biggest challenges in training AI models, because you gotta have enough data so your model can be generalized, can learn very good from those data. Right now, we only have like 160, which is nothing basically. But based on those 160, it can assign some weights and biases to our data and basically come up with the function that matches all the patterns that exist inside the data. Okay, so we're going to run it, and that's it. That's all you needed to do. So now your model is ready. So let's actually predict something. So now we're calling this predict method here. We're providing our test data. So look, so I'm just going to print the 5 of it. Basically, it is predicting some values here, but let's see how well it did. So we already have all the answers. Let's compare those with the actual answers. Let's look at some of them. So these are the actual answers we already have because it's a supervised learning. We already know all the target and labels. And these are our predicted values. So as you can see, this one, not bad, a little close. This one, not too much close. This one is not bad. This is not good. Some of them are good, very close. Some of them are not. So the model actually was able to predict some stuff, but as you can see, it's not precise. For different reasons, maybe we need to run the model a couple more times, maybe we need to optimize it. And the biggest probably reason is that we need more data. We don't have enough data here. So there are different ways we can evaluate our model. By just looking at these, that's not the way of evaluating the model. There are some mathematical formula that we can use to evaluate. There will be a different module for that we will get into all details, but we're just going to use some easy models here to get the score. The first one is going to be, we're going to use R squared. The score, basically, it tells us how well our model is predicting. And again, we're just going to run the score on our model. And this score method basically calculates the R square score. So right now, we are close to 0.9, which means there's a 90% variation in all the target values. So basically, it means around 90% it can predict the right answer, or at least an answer which is pretty close to the correct answer, around 90%. You really, this is actually, it's okay, but 90% is not good. You want to push it up as much as you can, again, for the lack of having enough data. This is the best we can do with linear regression, and at this point, probably if we provide more data, the model can learn better and we can improve this number. But you want to push it to 100%. You want to push it to like 1. Which is 100%. There is also another way of evaluating model, which is mean absolute error. There's a method, again, we already imported this one from scikit-learn, and this gives us a number. So this means like all the predicted values are off by about 1.46 points. So you want to kind of get this number down close to 0 actually. So again, there are different ways for evaluating models, but these are the very popular and common ones that you can use. So you want to get this one close to 1, you want to get this one down to 0. And we can actually look at all the weights and biases that our model generated. So if basically, like I said, it has a very simple formula for each input feature. It basically come up with some weight, and at the end it just adds a bias to it. This is what we call it a vector. So the data is just going to be the column and rows of input features. And when we say w dot x, we're referring to matrix multiplication, because now you're dealing with the matrix. Like the x is going to be two-dimensional data frame. So yeah, we can see all the coefficients, weights that it generated basically. We can also see the biases here based on different features. Sorry, we can also see like which one of these ways belong to which feature, and this is where we can see the bias. So basically, if we don't have any data input feature, so the predicted price is gonna start from this number. That's it. Very easy to follow. Here, I just came up with some numbers, see if our model can actually predict any price for this. So I just wanted to showcase like how you can use your model for predict new values that you might have. So you just use your model, you just give it your data, which has all the input features and their values, and your model generating, okay, that's going to be the sell price, the sell value. So let's also visualize all the y's that we use, all the target values that we use to test our model, and the y values that our model were actually able to predict. So as you can see, they're kind of close to a line. If we draw a line here, they're kind of close to each other, which basically means, you know, like they're 1.4 points off of this line, but they're pretty close. Like I said, our model can predict 90% correct, and that's why they're kind of a little scattered around this line if we draw a line here. But again, we're only using 160 data for training this model. So you really need a big data. Having a lot of data is a big deal in machine learning. So there are some practice for you. Basically, there's a data given to you here. Just follow the instructions, do the same process as I just showed you. It's a very easy process. All the methods are provided. We're just going to use all the implementation that we already have inside the scikit-learn. So enjoy, practice, and learn. It's going to be fun.